Good morning, boys and girls. It's day 2 of your week 6 packet. There should be a snowflake in the top right corner with the number 7 on it. Remember, this is a tool. Do as much of this page as you can first. Most of this is review. Then use this video to check your work and to get help on the parts that maybe you were stuck on.
One, two, three, comma, B. After 3, it's a comma, you see. And that first comma there, that's the thousands comma, didn't you hear? 1, 2, 3, digits for me. When there's 3, it's the hundreds, you see.
321.
When those 3 turn to 4, you pass the hundreds and the commas in store.
1,321.
Every time you see that first comma, just say thousand, don't ask your mama. Every time you see that first comma, just say thousand, just say thousand like this.
Say the number you see in front of the comma. When you see the comma, say 1,000. Then say the number you see after the comma.
9,402. 52,486. 255,321. 1, 2, 3, comma, B. More than 3, it's a comma, you see. And that first comma there, that's the thousands comma, didn't you hear?
1,321.
Every time you see that first comma, just say thousand, don't ask your mama. Every time you see that first comma, just say thousand, just say thousand like this.
Say the number you see in front of the comma. When you see the comma, say 1,000. Then say the number you see after the comma.
8,888.
Number, then 1,000, then 888.
88,888.
Number, then 1,000, then 888.
888,888.
Number, then 1,000, then 888.
1, 2, 3, comma. More than 3, it's a comma, you see. And that first comma there, that's the thousands comma, didn't you hear? Every time you see that first comma, just say thousand, don't ask your mama. Every time you see that first comma, just say thousand.
Now try to say these numbers on your own. Don't forget what to say when you see the first comma. $3,678. 57,821. 321,654.
1, 2, 3, comma, B. More than 3, it's a comma, you see. And that first comma there, that's the thousands comma, didn't you hear? Every time you see that first comma, just say thousand, don't ask your mama. Every time you see that first comma, just say thousand.
Just say 1,000. When you see the second comma, say million.
Question 1. Find the sum. 5 plus 6 equals 11. 1 plus 7 equals 8, plus 7 equals 15. Regroup or bundle the 10 over the hundreds. 1 plus 8 equals 9, 9 plus 9 equals 18. Write down your 800s, bundle the other 10, and move them to the thousands. 1 plus 4 equals 5, 5 plus 8 equals 13. Count your digits, 1, 2, 3, put your comma, 13,851. Number 2, find the difference. Difference is the answer in subtraction. 6 subtract 9. If I have 6 objects, I cannot take 9 away. I do not have enough. So I'm going to go to my tens and I'm going to take 1, which leaves me 2. Unbundle the 10 into 10 ones. I already have 6. Now I have 16. 16 subtract 9 equals 7. 2 subtract 4. If I have 2 objects, I cannot take 4 away. There are not enough. Go to your hundreds place, take 1 of them. That leaves me 3 hundreds. Unbundle that one and turn it into 10 tens. I already have 2 tens, so together I would have 12 tens. 12 subtract 4 equals 8. 3 subtract 6. I cannot take away 6 if I only have 3. I'm going to go to my thousands place, take 1 of them, which leaves me 5, unbundle it into 10 hundreds. I have 3 already, so now I have 13. 13 minus 6 equals 7. And then 5 subtract 2 equals 3. Count your digits, 1, 2, 3, and put your comma. 3,787. Number 3, find the product. Remember, when we're multiplying 2-digit by 2-digit, we are using an area model. So I'm going to go down here to my scratch paper and I'm going to use an area model. First, I have to take 62 and turn it into expanded form. That means I have to say what the value of the 6 is and what the value of the 2 is. The value of this 6 is 6 tens or 60. The value of this 2 is 2 ones or 2. Then I'm going to go to 29. The value of this 2 is 2 tens or 20. And the value of this 9 is 9 ones or 9. Now remember, it's the area model. Area, to find the area, you're going to do length times width. I'm finding the area of each of these rectangles, and then I will need to add them all together to find the area of the entire large rectangle. So let's start with this one. The length here is 20 times 60. Since I'm multiplying multiples of 10, I can count those zeros and put the same number of zeros in my answer. And then I can just look at this basic fact, 2 times 6. Go over here to your 2 and follow it until you get to the 6. And where they meet in the middle is your answer, 12. 2 times 6 equals 12. 20 times 60 equals 1,200. Then I'm going to come over here to this square, and I'm going to say the length 20 times the width 2. I'm multiplying a multiple of 10, so I can look at that 0 and put it in my answer. And then that leaves me a basic fact of 2 times 2. I see it right here in my multiplication chart, 2 times 2, which equals 4. 2 times 2 is 4, but 20 times 2 equals 40. Then I will do this rectangle on the bottom left. 9 is the length times width is 60. Again, it's a multiple of 10. I can put my 0 right there in my answer and then do this basic fact of 9 times 60. I'm sorry, 9 times 6. So I'll go here to the 9, follow it down to the 6, and where they meet in the middle, 54, that's my answer. 9 times 6 equals 54. 9 times 60, though, is 540. Then this last rectangle, I have 9 times 20. I have 9. This last rectangle, I have 9 times 2. That's just a basic fact. Come over here to your 9, then follow your 2 down, and where they meet, that's your answer, 18. 9 times 2 equals 18. Now remember, I'm going to take all these numbers and I'm going to add them up. Remember, when you're adding, it doesn't matter what the order is as long as you just add them. It's the easiest way to add is by putting your largest numbers on top. So I'm going to say 1,200 and then 540 plus 40 plus 18. Zero plus 0 plus 0 plus 8 equals 8. 0 plus 4 is 4, plus 4 more is 8, plus 1 equals 9. 2 plus 5 equals 7. 1 plus nothing is 1. Count your digits. 1, 2, 3. Put your comma. 1,798. So 62 times 29 equals 1,798. Okay, question 4. Find the quotient. So quotient means the answer in division. We're going to use another area model, but this time we're not trying to find the inside of these boxes. We're trying to find the top part. This total right here, 351, that's going to be the area of the large rectangle. And we're going to be splitting it into smaller parts to find the top. So I'm taking that first number, 351, and I'm putting it in my largest box. And I've divided it into 3 parts because I have 3 place values, 1, 2, 3. This number still goes over here on the side. Because I have 3 place values, I'm starting in the hundreds place. I'm still saying length times width. So 9 times 100 would equal 900. But remember, I'm trying to get as close to this total number as possible, but I can't go over. 900 is way over. So that will not work. That means then I don't have any hundreds and I'm going to put a 0 there. Then I'm going to move this number over here into the tens place. I can start with 10. Now, I know that 9 times 10, if you look on your multiplication chart, 9 and follow it all the way over to the 10 is going to be 90, okay? That's way too small. Since I'm working in the tens place, I know that whatever my answer is going to have a 0, right? And then I'm just going to multiply the front number with this number. So I'm going to look at these 2 front numbers, 35, and I'm going to say 9 times what could get me as close to 35 without going over. Let's go over to our multiplication chart, find the 9, and go until we can find close as possible to 35. 9, 18, 27, 36. Now 36 is too big, so I cannot use 36. 27 will have to be the number we use. If I go up, it's 9 times 3. So since I'm in my tens place, it's not going to be 9 times 3, it'll be 9 times 30. 9 times 30. 9 times 30, if 9 times 3 equals 27, then 9 times 30 equals 270. Now this is division, which is repeated subtraction, so I'm going to subtract. 1 subtract 0 is 1. 5 subtract 7, I can't do that, so I'm going to regroup, turn the 3 into a 2. Roll that 100 to 10 tenths, but I already have 5. Now I'm going to have 15. And subtract 7 equals 8. And 2 subtract 2 is 0. I have 81. I'm going to take that number now and I'm moving it over to the ones place. Now I'm thinking this is the ones place, so it can be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. But that's it. I'm going to go over here to my 9, and I'm going to follow it over until I get to as close to 81 as possible. 9, 18, 27, 36, 45, 54, 63, 72. Oh, I found 81 exactly. Follow it all the way up. It's going to be 9. 9 times 9 equals 81. I'm going to subtract those two numbers, and I see that 81 subtract 81 is 0. That means I have no remainders. Now, I have to still add all this up at the top to get my quotient. 0 plus 30 is 30, plus 9 equals 39. 351 divided by 9 equals 39. Now, since we know division is the opposite of multiplication, in order to, if you want to check your work, what you could do is take 39 and multiply it by 9, and it should equal it should equal 351. If it does, then you know you did it correctly. Question 5. Identify the missing number by determining the rule for the table below.
We're in a hot air balloon going up to fly. The table shows our time and height in the sky. At 1 minute we're 3 meters off the ground. At 2 minutes we're 6 meters up, staring down. At 3 minutes we're up 9 meters high. What's the rule that shows our place in the sky?
If we multiply any input by 3, we'll get the output. So that's the rule, you see. In goes 4, out comes 12. In goes 5, out comes 15, swell. In goes 6, out comes 18. The rule is times 3 and the view is pristine.
What's happening between the in and the out? We can always find out without any doubt. Make an educated guess and test it out, till you find what the rule is all about.
I have a function machine, the best you've ever seen. I put in a 9 and out came a 3. I put in 15 and out came 5. Then 27 went in and out came 9. There's only one thing I wanna know at this junction. What on earth is my machine's function?
If you divide any input by 3, you'll get the output. So that's the rule, you see. In goes 6, out comes 2 for sure. In goes 12, and you know out will come 4. This input-output table has a rule. It's divide by 3.
Man, that's pretty cool.
What's happening between the in and the out? We can always find out without any doubt. Make an educated guess and test it out, till you find what the rule is all about.
When there are two sets of values and they share a mathematical relationship of functions there, and we can use our mind, a mathematical tool, to find and describe the relationship called a rule.
What's happening between the in and the out? We can always find out without any doubt. Make an educated guess and test it out, till you find what the rule is all about. What's happening between the in and the out? We can always find out without any doubt. Make an educated guess and test it out,
exclusive content, lesson materials, and more. We test it out, y'all. Yeah.
So what they want you to do when they say determine the rule, they mean what did they do to this number to get it to this number? So you're looking for a pattern. Well, I could try counting up to that number. So 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, that's 8. If the rule is correct, then it should work for this bottom number too. What would 18 plus 8 be? Let's add it together. 8 plus 8 equals 16. Regroup the 1. 1 plus 1 equals 2, 26. Ooh, that rule worked for this too. So 18 plus 8 equals 26. 6 plus 8 equaled 14. Then I have to add 12 plus 8 to get this missing number. 12 plus 8. 8 plus 2 equals 10. Bundle it and move it to the next place value. 1 plus 1 equals 2. The missing number is 20. 6. Round the number to the nearest hundred. Remember, there's two ways you could do this. I have a number line. I have an endpoint at the top and an endpoint at the bottom, and then I have a midpoint. Round the number to the nearest hundred. Okay, so you have to look at the digit. Which digit is in the hundreds place? 0. There's a 0 in the hundreds place. All the numbers in the front will stay the same and everything else will become a 0. So for my bottom number, I'm just gonna keep the 5. The hundreds place will have a 0. And all the other numbers will also be zeros. Okay, 5,000. For my top point, I'm going to take what's in the hundreds place and I'm going to add one more to it, so it'll be a 1. So that'll be my top point. The 5 stays the same. The hundreds place will turn to a 1, but everything else will still be a 0. Then you look, okay, what is between 0 and 100? Well, I know that between 0 and 100 would be 50. Nothing in the hundreds place, and that 5 is still staying in the front. That's my midpoint. Look at this number, 5,095, and I have to determine where will it go on this number line. Is 5,095 above, greater than the midpoint, 5,050, or is it less than 5,050? Well, if my midpoint has a 5 and my number has a 9, that tells me this number is greater than it. So it's going to be right here above on my number line, 5,095. Because it is above my midpoint, that means my number will round to this top point, 5,100. Now we also learned another way. Learned a little chant. Find your place. My place is the hundreds place. Look next door. 5 or greater, add one more. This number is greater than 5, so I'm adding one more to this number. 1 more than 0 equals 1. All the digits in the front stay the same, so I'm going to bring them up. All the digits in the back zeros your name. All the digits in the back is referring to this one behind my place, the hundreds place. And there you go. 5,095 rounded to the nearest hundred is 5,100. 7. Draw a pentagon and partition it into 2 equal parts. Now we've learned partition just means put it into parts, and we want 2 equal parts. So I have my pentagon, And I'm going to go ahead and just draw a line, dividing it into 2 equal parts. Equal parts. If I folded this over onto each other, it would make 2 equal parts. Now, there really isn't another way to divide a pentagon. You could do it from any of the points like this. You could do it that way, or you could go ahead and do it through the middle this way. So you have to have one point and then through the middle of another line would make equal parts. You couldn't do it through 2 points because that would not make equal parts. Do you see that? You couldn't do it through just the middle of 2 line segments. That would also not make 2 equal parts. Okay, so just make sure that when you divide it and you think they're equal parts, that when you fold it over on top of itself, they should be the same size. Question 8. The shortest hill at the sled park is 999 feet long. How many yards is that? We just have to make an input chart then, and we have to think, okay, we know that 1 yard equals 3 feet from our measurement unit, 2 yards, 6 feet, 3 yards, 9 feet. I'm skip counting by 3s, but I want 999 feet. That's a lot. I don't want to count all the way up to 999. So what could I do to figure this out? That's right. I can go to some scratch paper and I can make an area model. And I'm going to have a divisor of 3 because I know it takes 3 feet to make 1 yard. And inside my box, I'll have 999. I see 3 place values. So what I'm going to do is divide my rectangle then into 3 place values. And I'm going to start with the hundreds place. 100 times 3 equals 300. I think I can get much closer than that. Since I know I'm working with multiples of 100, I'm a multiple of 100. I'm going to keep the 2 zeros in my answer. And then I'm just going to look at this first number. 3 times what equals 9 or close to 9? So I'm going to go to my 3 and see if I can get close to 9. And I found it exactly. I'm going to follow it up and I see 3. 3 times 3 equals 9. So I know that it can go in 300 times. 300 times 3 equals 900. Subtract those. 999 minus 900 is going to equal 99. Bring that up and move it over to your tens place. So I know this is the tens place. 3 times 10, that's going to be 30. But I need 99. Since I'm doing a multiple of 10, I'm going to go ahead and put my 0 there, and then I'm just looking at this first number. 3 times what would give me 9? Well, we actually already found that. 3 times 3 equals 9. So that means 3 times 30 then will equal 90. Go ahead and subtract those numbers. 99 subtract 90 is 9. Move that into your ones place. 3 times what is going to equal 9? Well, we have already found it. It's going to be 3. 3 times 3 equals 9 exactly. 9 subtract 9 equals 0. Now what I have to do is just add up the top. 300 plus 30 plus 3 is going to equal 333. The shortest hill at the sled park is 999 feet long. How many yards is that? It will be 333 yards. Let's move on to question number 9. Number 9 says use greater than, less than, or equal to compare the fractions. I can see right away that the denominators in both of my fractions are the same. We call that a like denominator. Because they are the same, I can simply look at my numerator to compare my numbers. 1 and 3. Which one is larger, 1 or 3? 3 is larger, so I'm going to put 2 dots next to the 3, 1 dot next to the 1, and then I will draw a line connecting them, and that will give me my right sign. 1/4 is less than 3/4. Number 10, find the area. Now they didn't give me the numbers, but they did give me the boxes, and that's okay because that's all I need to count. Remember, to find the area, it's going to be length times width. So let's count. 1, 2, 3, 4, 5. My length on this side is 5. Let's count the width. 1, 2, 3, 4. My width on this side equals 4. 5 times 4, length times width, 5 times 4 equals 20. Now to make sure I'm right, I could count the boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. The area is 20 because remember, the area is the inside. So I'll simply write A, which stands for area, equals 20. Because they didn't tell us our units on the inside, I can simply write units. But when you're working with area, remember, you have to write square units. And that's why you see these squares. 20 square units. The area equals 20 square units. That's it for today. I will see you tomorrow for day 3 for your week 6 packet. Bye-bye.